You know, in our digital world, pretty much everything, from your social media feed to your online shopping cart, relies on data that is just perfectly organized. But how does it stay so neat? Today, we are going to pull back the curtain on the magic that turns a total mess of files into a beautifully structured system. So let's kick things off with a problem I think we've all faced. Oh, we've all been there, right? You start a simple spreadsheet. It's clean, it's organized, but then a few weeks go by. Suddenly, it's a nightmare of duplicate entries, people are accidentally deleting things, and you have no clue which version is the right one. The whole thing just feels like it could break at any second. Because, well, it can.
All right, take a look at this. It's a simple students.csv file. Seems harmless enough, right? We've got an ID, a name, a score, attendance, pretty straightforward. But this simplicity, it's totally deceptive. We're going to use this exact file to uncover all the hidden problems that are just waiting to spring a leak in simple data files like this.
Okay, so let's really dig into the core of the issue here. This isn't just about things getting a little messy. No, there are some really fundamental reasons why using basic files for any important data is, well, basically a recipe for disaster. It pretty much boils down to 4 huge problems. First, they are super inefficient when you're trying to search or update stuff. Second, they have a really hard time with something called data integrity. Third, they just can't handle concurrency. And finally, the security is usually not great. So let's break a couple of the big ones down, starting with data integrity.
So data integrity, it's all about trust. Can you actually trust that the information you're looking at is accurate and consistent? In a simple file, it is so easy to accidentally type a name wrong or maybe enter a grade as good instead of the number 85. And boom, you've corrupted your data without even knowing it.
And then you've got this one, concurrency. This is a massive problem. It's what happens when lots of people, or even different programs, are all trying to change the same file at the exact same time. You can think of it like everyone trying to write on the same sticky note at once. It's just not going to work.
And this image shows you exactly what I mean. Just imagine 2 different teachers trying to update Rohit's grade at the same time. Teacher 1 puts in 80. A millisecond later, teacher 2 puts in 75. So whose change gets saved? Does the last one just wipe out the first one? It's pure chaos, and you end up losing critical information.
So with all these problems, how does anything in our digital world actually stay reliable? Well, this is where the hero of our story finally makes its entrance, the Database Management System, or what we usually just call a DBMS.
A DBMS isn't just a file. It's this powerful, really intelligent piece of software that acts as a gatekeeper for all the data. It's a sophisticated system that's been built from the ground up for one purpose: to manage information efficiently and, more importantly, safely.
And here's the crucial part. A DBMS is specifically engineered to solve the exact problems we just talked about. It has built-in systems to make sure the data has integrity, it knows how to handle lots of users at once, and it can enforce real security. You could say it's the adult in the room.
Now, there are a few different types of databases out there, but the most common one by a long shot is the relational database. The easiest way to think about it is like a collection of superpowered, interconnected spreadsheets. And that's what we're going to focus on.
So how in the world does a relational database avoid the chaos of a simple spreadsheet? Well, it all comes down to a really strict set of rules. And these rules, they're the entire foundation of its power and its reliability.
Here are the big ones. First, all the data lives in tables. Next, the values have to be atomic, which is a fancy way of saying each cell can only hold one single piece of information. So you can't just stuff multiple phone numbers into one cell, for example. Then, and this is huge, every single row has to be unique. No exact duplicates are allowed. All the column names have to be unique too. And finally, all the data in any given column has to be of the same type.
Okay, so this slide really gets to the heart of that every row must be unique rule. Look at this. We've got 2 students, both named A, both in the same batch, both with the same score. In a plain old file, they are completely indistinguishable. So how does the database tell them apart? This is the central problem it absolutely has to solve.
And the solution to that whole uniqueness problem is actually really elegant and super powerful. It's a concept called keys. Keys are the secret weapon that let a database give every single row its own unique, undeniable identity.
To put it simply, a key is just one or more columns in a table that, when you put them together, can guarantee you are pointing to exactly one row and no other. It's kind of like a fingerprint for each piece of your data. But you know what?
It gets even more interesting. It turns out not all keys are created equal. And to really get how databases work so efficiently, we need to look at two specific types, superkeys and candidate keys. So let's compare them.
All right, first up, we've got the superkey. A superkey is pretty straightforward. It is any combination of columns that is guaranteed to be unique for every single row. It does the job, but it might not be the most efficient way to do it. Just look at this table here. A student's email address is going to be unique, right? So the email column, all by itself, is a superkey. But the combination of email and name, well, that's also guaranteed to be unique. So that combination is also a superkey. You can see how we could start to have a whole bunch of possibilities.
And that leads us perfectly to the candidate key. A candidate key is special. The definition is that it's a minimal superkey. And that word, minimal, it's everything. It means it's a superkey with absolutely no extra redundant columns. If you take away any single part of it, it's not a unique identifier anymore.
This right here illustrates the difference perfectly. So in this example, the combination of the student ID and the batch name is unique. And if you remove either one of those, it stops being unique. That makes it minimal, which means it's a candidate key. But now look at the next one. Student ID, batch name, and the score. That combination is also unique, sure, but the score is just extra baggage. We don't actually need it to guarantee uniqueness. So it's a superkey, but it is not a candidate key.
So let's put it all together here. Do they both guarantee uniqueness? Yep, absolutely. But is it minimal? Well, for a superkey, not necessarily. For a candidate key, it always is, 100% of the time. You could say a superkey's goal is just to find any way to identify a row. A candidate key's goal is to find the best, most efficient way.
So here's the big takeaway. All candidate keys are superkeys, but not every superkey gets to be a candidate key. Really, a candidate key is just a superkey that's been stripped down to its most essential, efficient form. It's the clean, elegant solution with no extra baggage.
Which of course leaves us with one last really interesting question. A single table could have multiple candidate keys, right? Multiple perfect options for the job of being the unique identifier. So how does the database decide which one of those gets to be the real boss, the one and only primary key? Well, that sounds like a story